The report presents the technique of remote thermovision research during a predictive assessment of the presence of solid minerals. The work was carried out on the Bay of West Java plot, Indonesia, as a verification area of 76.7 square kilometers for PT Asia Sejati, Indonesia. The purpose of the work is to demonstrate the capabilities of thermovision tomography of the geological environment technology and to assess the geothermal factors in the forecast of the ore field. A patented technology was used in the project. The materials were processed using Terramotis and Landsat-8 spectrozonal satellite images in the thermal infrared wavelength range, with a spatial resolution of 500 to 10 meters. According to geothermal features, the territory was ranked by the prospect of ore bodies. Complexing of geomagnetic and geochemical surveys with TVT data was conducted. Methodical basics of thermovision tomography. The essence of space thermovision sounding technique when searching for minerals consists in processing and interpreting multispectral images in several stages. According to the developed algorithms, a three-dimensional model of the thermal field, maps and sections of heat sources and block fault structures, the spectral brightness of the anomalous zones of mineralogical indices are being constructed. The next two slides show the mathematical foundations and algorithms of thermovision tomography. The basis of the developed algorithms include solving the inverse problem of the boundary value type for a thermal field, with the construction of a model of block fault structures. The calculation of the local field distribution model is carried out by a two-dimensional wavelet transform based on the source function method. According to the form of block fault structures, geological objects can be classified. In the process of numerous works, we have collected extensive information on the orientation of faults and dikes, on ancient and young grabens and horsts that have retained their activity in a thermal field. For example, at the top of the slide are three volumetric horizontal models of block fault structures at various depths. One can see how the shape and size of the blocks consisting of dense rocks, white and bluish, change along the depth. Geodynamic zones of compression and tension of inhomogeneities are also clearly distinguished. The bottom figure shows a vertical TVT profile to a depth of 3 kilometers, a block fault structure. One can clearly distinguish graben, letter A, and horst, letter B. Here, dense rocks are colored in red and yellow, decompacted rocks in blue color. Fault tectonics and calderas, buried in the volcanic sedimentary layer, are the main priority in the search for ore deposits. In the central part of the slide, a vertical section is presented, block fault structure to a depth of 5 kilometers. An intrusive body, dense rocks of red and yellow color, is clearly visible in the center part, from which numerous dikes branch out, dense rocks of yellow color, towards the Earth's surface. The method of thermovision tomography of the geological environment is used in many countries around the world, in the search for hydrocarbons and ore minerals, water and geothermal heat sources, in solving technogenic problems. A priori information for the implementation of this project. Geographical coordinates of the site. Information on the genesis of ore deposits in the region. Digital material of aeromagnetic shooting. Fragments of information of the deep geochemical survey. The initial TVT material for research is spectrozonal images by satellites MODIS and Landsat-8. Space images do not contain natural and artificial interference. The high quality of infrared images allows us to study in detail the geological structure of the territory in search of ore fields. Real media have zones with inversion of the thermal layers in depth. One of the important results of studying the heterogeneous systems of the region is the establishment of heterogeneities with regional distribution in the structure of the Earth's crust, in particular, the tectonosphere. The section Regional Profile, Block Fault Structures in the bottom left of the slide shows a regional zone of decompaction of rocks, blue color, which is monoclinic in shape and ascends to the day surface at an angle of 70 degrees to 30 degrees from the lower part of the crust, about 30 kilometers. In the upper part of the model, this zone acquires a horizontal position with a thickness of about 5 kilometers. It is assumed that this part of the medium is saturated with deep fluid, which was formed as a result of rock dehydration. Ascending high-temperature fluids participated in the process of lifting and subsequent concentration of ore elements in the upper layers of the sedimentary cover. It can be assumed that the temperature layers in the crust are gently inclining dislocation zones. This explains their overlap on different aged material structural complexes. For a detailed analysis, Landsat spectrozonal infrared satellite images were used with a spatial image resolution of 10 to 60 meters. Detailing of the site was carried out with a spatial image resolution of 10 meters. The depth of study of the thermal field amounted up to 6 kilometers. The depth sign for the search for ore structures are sections of the thermal field, where the magnitude of the field gradient from deep sources reaches maximum values. 5 local heat sources of different intensities are distinguished in the study area. Of greatest interest is Zone A, high priority, located at the intersection of two TVT profiles, 2 and 7. Zones B and C are of medium priority. Zones D and E have a low field intensity and the status is unknown prospects. The outline of the block fault structures in the horizontal section allows us to trace the interval inhomogeneities of the medium in the plan. Large dense bark blocks, blue and white color, and decompacted medium of a linear view, faults, or a spherical view, camera, yellow and green shades of color, are clearly displayed on the map. Reliable information is obtained by calculating the increment of sections of block fault structures for different depths. The increased content of ore elements should be associated with an increase in the amplitude of folds, exactly with their apical part. The most preferable conditions for localization of mineralization are the areas of intersection of hidden faults, a system of small adjacent faults, and a thin fracture zone. For this reason, weakly defined faults between blocks, the areas of permeable disturbances located at some distance from them, have a decisive influence. In such zones, the filtration flow is low, a higher concentration of solutions is formed, and as a result, the localization of mineralization and associated elements. The effective injection of ore-bearing solutions is noted by intensive heat exchange with the host rocks. 3 pictures on the left side of the slide show vertical models of the integral field of block fault structures and heat field sources of the sedimentary cover along profile 2. On the right side, map of local block fault structures in different depth intervals. A high-precision digital terrain model has been compiled. The relief emphasizes the morphology of the structures, which retains its shape at shallow depths. Morphostructural analysis of the digital relief model allows us to trace the local drift of ore elements. Numerous maps of the reflectivity of rocks on the surface are compiled. Using the full spectral characteristics of the object based on spatial filtering of signals, it is possible to obtain specific data in the diagnosis of the environment. The inhomogeneities of the energy brightness are linked with the natural objects and minerals under study. For example, in the process of the formation of oxidation zones, the epithermal ores are overlapped by powerful intensely colored iron hats consisting of iron oxides. In the process of weathering, pyrite, ferrum sulfur 2, widely distributed in altered host rocks, turns into limonite and hematite. Pyrite serves as a good prospect sign for the ore deposit's exploration. Therefore, it is advisable to jointly consider NDLI maps and magnetic field sources. The following conclusions are drawn from the analysis of the field pattern and sampling location of the ore substance. First, the maximum values of the ore substance fall into the dome of a dense structure and into the region of the maximum gradient of the thermal field. Second, the winding shape of the gradient zones of heat sources, red winding lines on a white background, may indicate areas of ore concentration exploration. Third, the location of known ore concentrations coincide with the ascending gradient zones of heat sources in the bottom left of the slide. The morphology of the thermal field patterns made it possible to recommend new promising ore deposits. Fourth, a detailed study of the thermofield of the sedimentary cover allows one to detail the ore zones in plan and depth. Fifth, thermal characteristics are identified, according to which regional and local zoning of the territory should be carried out during the exploration of ore bodies. Using a priori information of the initial geomagnetic field, the values of magnetic sources were processed and calculated according to an algorithm based on the natural, continuous wavelet transform. Local magnetic sources have been identified that allowed zoning of magnetization in plane. The vast majority of sources are located in the uppermost layer at a depth of up to 200 meters. A slight increase in the number of sources is observed at depths of about 1,000, 1,500 and 2,400 meters. Maps of the interval values of local excess magnetization and sections of the magnetic field sources along the profiles are constructed. A correlation was established between high values of the magnetic field and dense TVT blocks. An uneven distribution of sources in the plan can be noted. In general, the magnetic field is fragmented, which is reflected in a high concentration of sources with small sizes at a shallow depth. The connection is traced during comparison of the sources of the interval geomagnetic field with the geochemical anomalies of ore minerals. At the epicenter of the maximum values of excess magnetization, as a rule, geochemical anomalies do not appear. The location of the survey points falls into the gradient zone of the source, which is located in the edge part of the magnetic body. The result obtained is of fundamental importance in the search for ore deposits that contain ferromagnetic materials in the geological environment. The close properties of the elements of the triad, of iron, cobalt, nickel, to a large extent predetermine their joint presence. Therefore, the establishment on the map of the location of local anomalies of isomeric outlines in the depth interval of 100 to 150 meters is a priority task for further research. Detailed analysis of the high priority area. An example of a local map of block fault structures at different depths is shown. One can see an annular body, caldera, along the edges of which there are areas of maximum concentration of ore substance. Block fault structures change their shape and plan as the depth of investigation increases. At the depths of more than 200 meters, an isometric structure appears with a high density of rocks. The local uplift is the marginal part of the caldera structure and may relate to the mother ore body. The new promising zone is located on the continuation of the anomalous zone of size or concentrations. Anomalies of spectral brightness and other thermal signs are clearly distinguished within this zone. The developed thermal model of the genesis of ore field formation forms the basis of methodological recommendations during the TVT survey. As a result of analysis of TVT materials, 1. A physical model of the environment and geological natural factors that form the ore field of the region have been established. 2. The thermal signs of ore zones have been established, which can be successfully used in zoning the area. The structural tectonic factor gives a qualitative understanding of the processes of formation of the ore field and the geological environment. 3. The cited material allowed us to identify a causal relationship between the anomalies of thermovision tomography and accumulations of ore bodies in sedimentary complexes of the cover. Some predict TVT criteria are formulated, which are manifested with varying degrees of reliability for the ore field. 4. According to TVT interpretation results, the West Java site in the regional plan should be attributed to a promising area in the search for ore bodies. On detailed level, zones are identified that are classified as high or medium priority and unpromising 1. 5. The possibility of successful application of the TVT method in the search for ore minerals has been proved. This will allow the customer to reduce the time and cost of geological and geophysical work. Thank you for your attention.